Hey everyone, so today we're going to learn how to solve one-step equations, which is one of my favorite things really to do in algebra. So you should have notes that look like this when you got them, and you're going to fold them right along the edge here so that you have a sheet that looks like this, and you're going to cut right up to that fold. So if you open this up, you're going to cut right up to that fold underneath each one of these rectangles so that you have a fold, a flap for using subtraction, a flap for using addition, and so on. So once you get that done, then go ahead with the video. All right. So if we open up our using subtraction flap here, we're going to note that if we see an addition sign, we're going to subtract. So we're going to do opposite operations or inverse operations. So we'll always use opposite or inverse operations. And as you'll see as our notes go on, you'll always do the same thing to both sides of the equal sign. That's so important. Always do the same math on both sides of the equal sign. So those are our two rules for solving one-step equations. I'm going to highlight those because they're really important. We want to use opposite or inverse operations, and we're always going to do the same math on both sides of the equal sign. Okay, so you have an example here. If we see addition, we'll subtract. Well, we see x plus 41 equals 50. And our goal is to isolate this x. We want to isolate the variable. We want to get it all by itself on one side of the equal sign. So that's our goal. Let's write that here too. Goal. Variable by itself on one side of the equal sign. Doesn't matter which side, just so it's on one side. Okay, so here you see in our example, this was x plus 41. We subtracted 41 from both sides of the equal sign. This has to be kind of kept in balance. Whatever we do on the left side of that equal sign, we have to do on the right side of that equal sign. So our 41 minus 41, that's gone because plus 41 minus 41 is 0, and x plus 0 is just x, and then 50 minus 41 is 9. So we subtract from both sides, pull down the x, and solve 50 minus 41. So you've got those little notes over here for yourself just as a reminder. So again, this is if we have an equation that has addition in it, we'll be subtracting. Okay. So let's look at our example here. We have y plus 15 equals 57. So we're going to try to isolate y, get y all by itself. We're going to do that by using inverse or opposite operations on both sides of the equal sign. So on this side of the equal sign, I'll be subtracting 15. I want to keep this balanced, so on this side of the equal sign, I'll be subtracting 15. We're going to pull down the y. This is gone. That's why we did it. And we just do 57 minus 15. So 7 minus 5 is 2, and 5 minus 1 is 4. And so our answer is 42. So we can check that. We can go back and we can check that. We could put 42 in for y, and we could work out, is 42 plus 15 equal to 57? This is our check. We're checking it. So we could add 42 and 15 and make sure that it actually equals 57. If that's true, we did this correctly. And this is our answer. This is what we're looking for, this y equals 42. That's our goal. All right. So let's look at using addition. If we have an addition problem, if we see subtraction, Then to solve that, we're going to use addition. We're going to do the opposite. And so you can see in our example here, it's x minus 50. So we added 50 to both sides, and then we pulled down the x and solved 61 plus 50. So let's look at what an example looks like over here. We've got p minus 7, so we should do opposite operations. We're going to add, well, I like to circle the variable, so I know I'm trying to get that all by itself. So I'm going to add 7, and I've got to keep this balanced, so I add 7 over here. Again, since the equation was a subtraction equation, we'll be doing addition. We're doing the opposite. So we know that 7, a negative 7 and a positive 7 is gone, and we just bring down our p. And now we need to add 18 and 7, which is 25. Okay, all right, let's look at a problem where we would use division to do the solving. So if we see a multiplication problem, then we would divide. So we would divide on both sides. And you can see here our division looks like this. Remember, when we have a variable x next to a number 3, that means multiply. This means 3 times x. So we're going to divide by 3, and using that fraction bar with a 300, that means divide by 3. And then 15 divided by 3. So we would pull down the x, which is what we did here, and then we would do 15 divided by 3, which is 5. So let's look at an example over here. So we've got 5 times m, remember 5m means 5 times m, equals 20. So we see multiplication, which means we're going to do division. So we'll divide both sides by 5, keeping this in balance, and we want this m all by itself. Okay, so we're going to bring down the m, and 20 divided by 5 gives us 4. So divide on both sides, pull down the variable, in this case is an m, and then solve the other side of the equation. All right, so I bet you're getting this already, but if we have a division problem, if we see division, then we're going to multiply. So if we see in our problem that it's a division problem, then we will do the operation multiplication. Oops, let's just make that multiply. Okay, so you can see in our example here that this is x divided by 7. Remember that fraction bar means divided by, equals 5. And so we multiply by 7 on both sides. We bring down the variable and then do this problem. Okay, so multiply both sides, pull down the variable, and solve the problem that's left on the other side of the equal sign. All right, let's look at an example. So I want this n all by itself. This is n divided by 8. The opposite operation for dividing by 8 is multiplying by 8. Pull down the variable, n, and do this multiplication problem, 91 times 8. Well, 8 times 1 is 8, and 9 times 8 is 72, so that's 728. Again, these are our answers. These were the numbers we were going for. And just a reminder, I could put 728 back in this problem. I could say to myself, is 728 divided by 8 equal to 91? That's my check. That's what I love about these. You can check to see if you have the right answer. And sure enough, if we took 728 and divided it by 8, we would get 91. All right, now I want you to stop the video. Actually, I'm going to stop this video. I want you to do these 4 problems following the examples that you have, and then watch the next video to make sure that you did them correctly.